Hello. Not many introductions. This is the last thing that we will be doing for PBA Bali. It's a restream, streaming about jump. It's the jump panel with Dr. Gavin Wood, Kian Paimani, Mathieu, Sean, and Cisco. So give it up and let's get it going.
How do we start?
There are no questions.
I mean, I actually have a question that I wanted to ask. One of the things was mentioned is that JAM is transactionless, right? Is this particularly important to you? Like, is this, I mean, obviously for people who is all here in blockchain, we know about transactions, like the thing that we interact with. Is that like a really important decision?
Fairly. I kind of see as, can you hear me?
I don't think that's on.
I think it's off. Maybe the button.
Okay, that's better, right?
Yeah.
Yeah, basically, yes. Like JAM's designed as a general decentralized computer, right? And transactions represent one particular usage pattern, albeit a very common one in decentralized computers. But you know, it's this same thinking that led us to having the relay, like this thinking of like, let's design around the use case that we see right now that led us to the current architecture of the relay chain and the inability for it to support core play, right? And core VM and all the rest of it. So it's like transactions are pretty opinionated things at the end of the day. You have to work out, for example, a payment system. You have to work out like a gas limitation system. You have to work out some sort of queuing and execution framework for them. And these are all very opinionated things, especially when you get into stuff like MEV and you start wanting to argue over who gets to say and in what context they get to say which transactions make it into a block and in what order. So I'd rather not have that stuff at the core protocol level, because it would just complicate matters and probably force us into opinionated decisions that would become invalid in 2 or 3 years' time. And instead just leave it for the layer 2, or whatever you want to call it, services to figure out.
Hey, Marcin here. I have a question. What's the difference between scale codec and gray paper codec?
Mostly it's one of variable size integers. So this was changed in the gray paper to reflect a more standardized way of doing it and also just generally a more sort of sensible way of doing it. The scale version of it is kind of quite heavily optimized to what the needs were at the time, which is basically encoding the length of lists. Whereas the gray paper one is, I forget what they call it now, but basically it just has an equal weighting for each of the powers of 2. So basically as you go up by powers of 2, or specifically powers of 2 to the 7, powers of 2 stepped by 7, then you use 1 extra byte. And you can, it's got quite a nice thing. You can count how many bytes you want by basically, I think it's the number of ones or zeros at the beginning of the encoding, -1 or something. So it's quite elegant. And for what it's worth, the general design of this encoding is some old computer science thing, right? Probably in, what's his name? Tannenbaum? But, Knuth, I guess. But the specific encoding is one that Young came up with because it happens to work quite effectively on modern CPUs.
So I think one problem that Polkadot has not proven yet to be able to overcome is to make building easy. Now, what is the strategy there with Jam? Because you're going to introduce new services, and there on top of these services, you again need to, like, I don't know, provide all the tooling and everything, blah, blah, blah. Like, besides having this relay chain, which is going to be more stable, like, what other things can be done to, like, make that better, faster?
I'm not going to take every question, so there's some other Jam builders here.
I can maybe start it, maybe go, but I think one of the things that's really important is usually, if you make things easier in terms of like building or like SDKs or APIs, usually it involves more opinionation, right? So that's why it's easy, because you don't have to make a lot of decisions. You don't make a lot of decisions because the API or thing pushes you down a certain direction. I think what's super important if you're building a general computer is not to, I think number one focus is not necessarily to make it easy, but to make it general, to make it useful. And I think teams like yourself, like you're on POP, and your goal is to make things really easy for the users by making those opinions. And I think one of the mistakes I've seen in the Polkadot ecosystem, which has not led to this simplicity, is that those developers actually building the end UIs or building the end interfaces are not themselves taking enough opinions. I'll give you a simple example. If I go to PokeAssembly, what I see as a runtime developer is I see basically every single possible extrinsic, every single possible button you click, every possible option and parameter is just exposed as a field in the PokeAssembly UI. This is the most simple way for a person to make a UI, just map it one-to-one. We made decisions in the runtime that kept things to be general and flexible. It should have been people like PokeAssembly or Subsquare taking opinionations on this is how we want to see a structure of a government proposal go through, and then to apply those opinions across to our APIs. I just think that for whatever reason, we haven't found people who are either have that vision or are inspired enough or feel, or maybe we break things too fast. It could be our fault too. But I really think that it's not the job of this protocol, but the job of the end developer. So I hope like teams like you, like POP, will actually take more opinions and make things easier for the paths you think are most important.
I think that covers really the main part of it. One additional point I would add is that with Jam, there's this new attention on, because we have a new VM, and different teams are implementing it. I'm aware that different teams are also interested in now trying to build SDKs for it. So with Polkadot and the WebAssembly bytecode, we pretty much stuck to frame all the, this was the only way you could produce this bytecode. Now we have a Rust SDK, but there's also others being created by different teams. So I think this attention towards the VM is encouraging more people to build SDKs for it. And as Sean said, hopefully those SDKs would be more opinionated this time, in different ways.
Yeah, because I think that is kind of it is maybe also a little bit of the responsibility of the people that build this low-level generic thing. You guys have the knowledge. Like if there's not, like it's kind of like you're making something very complex and very powerful, but you leave it up to the persons one stack up to like be opinionated and yeah, like make it easier. So I think I agree, but I think there is some like collaboration there or some shared responsibility to quicker make it easier so that you can get people to actually build on it, get feedback, and improve. Yeah.
Also, to add a tiny bit to that, I think the approach is slightly shifting. Initially, when Polkadot and Parachains were launched, the main thing was building parachains. And there is a curse and a blessing side to building parachains. You get control over the infrastructure. Some people love it, some companies love it, some companies hate it, and it's a lot of extra hassle and cost. And I think it's changing now, especially with something like Polkadot Hub, where we're trying to make it more easy to natively deploy just smart contracts, where you don't have to worry that much about infrastructure. And some of those like paradigms are moving over to Jam and will still be relevant in Jam. So I think the change is already happening in this regard.
And regarding collaboration, I do agree that we need to collaborate a lot with teams that want to make this easy to use. And I believe that is going to be one of the priorities moving forward. Like, it's first the paper, which is still not done. Then all the teams are working together to get the networking, also the networking standards. And then some students were mentioning the like interoperability standards between services. Like all those things, they're not written into the core protocol. They need to be done by different teams because different teams will add different opinions that will make it easier to be used by different people. Because some people prefer to code in some language or in some paradigms, and others they prefer to use it in another way. But I believe it will be a priority to collaborate between like Jam implementer teams and anyone that wants to make this easier to use.
Yeah, so just to add on to that, actually I think targeted for December, there will be a sort of Jam retreat run by the very same team behind the academy, intended to get the ball rolling on this specifically. The middleware, the interop standards, the APIs and SDKs, and try to do so with end user applications in mind. So to do this specifically, we're going to see if we can actually build some end user applications and then basically see what's missing. We're not going to be so gutted if we get to the end of the retreat and we don't have end user applications, but rather have a shopping list of middleware that we need to build. But the idea is to actually run this over a number of months, with the idea that 3 months later, we've built the middleware, at least the initial versions of it, and we actually can deliver the end user applications.
Hi. My question is, like, I'm a little bit bugged about the direction and kind of branding and marketing, because it seems to me, and this slide is the example, that Jam is kind of like presented differently from Polkadot, but in my head is kind of a major technical upgrade. I mean, a complete redesign, right? Mm-hmm. But this will be part of the Polkadot brand, or will be something totally different? And how it will look like? Because we will have Jam cores and relay cores. So we will have a relay chain that is basically using one or multiple Jam cores. So it will be, yeah, it's a little bit kind of confusing.
Right, so the relay chain will be retired in favor of the new Jam chain when Jam is ready to take over. Right, so there's not going to be relay chain cores and Jam cores running at the same time, at least not for Polkadot. Maybe Kusama's going to have Jam cores and the Polkadot's going to have relay chain for a while during the transition. I totally understand your point with regards to communication and branding. But you see, we're in a slightly tricky position here. You're correct that the technology is very much a reboot. Some of it will be compatible, like the Parachain's SDK. But essentially, to all intents and purposes, what constitutes the Polkadot chain will be totally replaced with new code, new protocol. And so it's, I would say, actually quite important, to the extent that we want to attract people on the back of that change, to make clear that this is a new technology. Think of it like a rebranding of Windows 95 to Windows XP, right? It's like,
but will still be like kind of Microsoft, right? It will be still Polkadot, like the main umbrella, the main tech powerhouse.
Unless governance tells me any different, yes.
So essentially, we'll be swapping kind of virtual computers from a kind of old one, the relay chain, to a much more new ones, the gem chain.
That's right.
Okay, thank you very much.
On that note, I think that like I know things are being done in a way where governance has the final say, and Jam is a protocol, and if Ethereum wants to use the Jam protocol, they can, and it's not, like it's a specification, it's not meant to be like Polkadot focused, necessarily. But I do think there are some things going on in governance where they are, like people are not sure what the like leadership is taking, where the direction they're taking. So for example, there are some proposals like from Fluffy Labs. There was a proposal for the Jam reader, which before they did a proposal for the Jam, the Jam reader, and that's like they got the funding. But then for the Jam search, most of the comments were like, this is Jam. We don't know if like DOT will die and the new Jam token will appear. So until we know, we nail it to oblivion. And so yeah, in my mind, it's pretty clear that there's a distinction, but also they're kind of symbiotic. But I think that the overall community didn't still get that memo, and maybe something should be done there.
Yeah, I think this is partly my fault. But I think also it, at least in my head, is very clear. I think governance has made by and large their sentiment clear, and there is now alignment. So I don't really see this issue happening again. I think it was a reasonable consideration. I think if the consideration didn't happen, it would have been remiss. But I think to all intents and purposes, the decision is made, and it's time to push forward.
Hi, Carlos here. My question is, so we like Jam, what would be the best ways to contribute?
What was the last word? Sorry?
What's the best way to contribute?
At this stage, you can download PokerJam already. We publish binaries and play around with services. I mean, it's pretty raw. I think we are actually slowly getting to the point where we will regularly release SDK upgrades along with the PokerJam binaries as the protocol moves forward. So there's that aspect. You can also build an implementation. But you got to remember at this point, it is work in progress. It's in development. So, there's a reason why PBA is teaching Palette Revive and not how to code on Core VM. Yeah. Palette Revive is ready. Core VM isn't.
Yeah, but also, like, at this point, the same way, like, PBA is showing about Jam, like, anything helps as a contribution, just like reading the paper, reading the docs that the teams have assembled, spreading the word, yeah, playing around. But it's not like you can, I mean, thinking how things maybe should look like because of what we said about how to make things easier, like if you understand the architecture and if you educate yourself on it, then when it's ready, you can contribute better. So right now, contributions with code, probably very minimal or very raw, but like educating yourself will always work, or like spreading the word will always work, so that later you're prepared for when it launches, for example.
Yeah, I mean, adding on to that, in principle, you could start developing SDKs, right? There is already published binaries and basic APIs. There's nothing that would stop you from building on that and making service SDKs. And as we said before, the desire is to have many different SDKs, each with their own set of opinions to make particular application development mindsets easier.
So for example, like we have the Rust one, we're building the C++ one because it's just the easiest ones to compile to PVM. But then what about, I don't know, an SDK in Python, in Java? Like there are so many things that it might be very raw, very experimental, not any docs. But if you investigate them and work with them, that they are all fair contributions. And even then, like SDKs that don't just expose, refine, and accumulate, but rather expose some other APIs that use refine, accumulate under the hood, but that like make opinions on how some particular types of services might be built. All those things would be helpful, I think.
Also,
Sorry, real quick. The very first thing that I did at Parity was actually write a document which did the demo that Gav showed, where he opened a new MacBook and then launched a blockchain and did a quick palette and did it. And so, I mean, I absolutely can tell you, I did not know anything about Substrate or anything about what he actually did there, but I was able to replicate it by following that video and at least put that information out there so other people can replicate it as well. And I think that you've seen a couple cool demos during this academy. 100%, even if you are still learning, your ability to document that demo, put it out there, and share that information, I think is a great contribution.
yeah, definitely that. And on top of that, you know, not everyone has to build an implementation. You don't have to start your own new one. There's a bunch of teams already. Get in touch with them, see if they need help, especially the smaller teams. Like we want to, as many of those teams to actually get to the finish line or as far as possible. So I'm sure there will be some teams that need the help and support.
Hi guys, my question is about the release cycle on Jam. So most parachains in the ecosystem say if it ain't broke, don't fix it. And that's why they don't follow the releases on Polkadot SDK, which are every 3 months. And if you absolutely have to bring in new features, it's really, really painful. So what will the release cycle on Jam looks like? Should we gear up for incremental changes every few months, or are we looking at major changes every few months?
So, I mean, Jam itself is more akin to the underlying machinery of the Polkadot relay chain, think like validator executable. It's not like the SDK is something that would that is more. I mean, as it happens, Polkadot SDK is somewhat shared between the validators and the Parachain stuff. But in Jam's world, the Jam node binary has nothing to do with the Parachain's SDK. What this means is that we can probably release, well, there might not be quite so much tying the Parachain's SDK to a 3-monthly cycle. More importantly, we can imagine there being many different SDKs, all independent, all able to sort of use Jam / be used by Jam, whichever way you look at it. And all on their own release cycle, right? We've just got more independence within the SDK universe. And this is really helpful because it might be that you want a nightly SDK, a beta SDK, a stable SDK. Yeah, we can't really do that so easily at the moment because Parachain runtimes, broadly speaking, are expected to be running the same thing as the relay chain runtime, and the relay chain runtime is kind of expected to have the same code as the validator node implementation. So this creates this kind of annoying dependency blob. Yeah, Jam will facilitate us in breaking the blob.
And to expand a tiny bit on that as well, I think Substrate and Frame were made to build upgradable blockchains easily, and the Polkadot relay chain as it stands is also built with Substrate and Frame, which makes it very upgradable, which sounds good, but then we have very little friction in actually upgrading it. So all the core devs are constantly making changes, minor improvements here and there, because we always felt like, why not improve it now? Why wait? And it has been a pain point for the ecosystem, which I think many people have realized. And the intention, from what I see, is that Jam will not be as immediately upgradable. So we have to be really conscious of, if we are making an upgrade, make it concise, package everything together, and really think when we are doing it and how we are doing it. So we're not just constantly pushing the changes all the time.
Yeah, I think the release cycle was proposed to be like every year or year and a half.
Yeah.
It's do like a hard fork like Ethereum does, and then yeah, you develop it over a long period of time, and then at one point you coordinate and you do it. And so I think the most important thing for Parachain teams is that right now they are very dependent. They depend on like the relay chain code, and they kind of need to update their SDK very often. And yeah, with Jam they can expect a more stable environment where the relay chain, so like the carpet beneath all of the parachains will not be stolen like from underneath their feet. So yeah, you can expect more stability, which I think is another one of the things, like it was not the main motivation for Jam, but I think it's one of the things that is really important and really useful about Jam, is that it will bring stability to the current teams, which is very much needed.
Yeah, so you can think of Jam as basically, as I was talking about earlier, it's the decentralized hardware, right? And it's, as you know, Sean brought up in his first question, it's very unopinionated. It doesn't have a concept of transaction, right? It's very unopinionated. It's really just there to coordinate validators to ensure this computation happens. And as decentralized hardware, you can kind of put it on the same upgrade cycle as a server hardware, right? It's like hardware does get better over time, but you don't need to update it every 2 weeks, right? You update it every, I don't know, 18 months maybe, yeah? And that's the sort of upgrade cycle that I see Jam taking. And it's going to be more painful probably than upgrading the relay chain. But then also probably not, because any serious relay chain upgrades come with a lot of, well, basically host call alterations or like host environment alterations that mean you can't just upgrade the WebAssembly. You actually have to upgrade all the nodes as well. And if you don't, then things go wrong, as we have seen once or twice on Kusama. So I don't actually see this sort of hard fork upgrade path as being desperately worse than what we have at the moment with relay chains. In fact, if anything, it's just really laying out what the reality is. And the nice thing is that we can upgrade the services individually, because the services are all contained as their own little PVM blob, right? We can't do that on the relay chain. Yeah? On the relay chain, it's like upgrade everything or upgrade nothing. Yeah? With Jam, we can say, right, we're going to keep all of the services exactly the same, apart from, I don't know, the staking service, which we actually do want to upgrade. Yeah? And the fact that we can do this really limits our exposure and allows us to have much more fine-grained upgrade cycles for the bits that we want to change.
Okay, so I just wanted to mention that a month ago there was a rejected proposal on government from Colorful Notion about changing DOT token to Jam token, and yeah, it was rejected. So I think it's pretty clear what network wants. But what is the statement for current situation? Like, is there any statement about that?
What do you mean, what's the statement? As in, was this our opinion?
So, like, there was a proposal, but people still don't know if we're gonna pay with DOT on Jam or there will be a separate token.
I mean, I think it's that just people want to follow a leader, but in theory the statement was made by OpenGov, and the protocol just says there's some balance, and yeah, and Polkadot it will be DOT if people don't want to change. I think the change into Jam was just changing the branding so that people thought, hey, this is a brand new thing, we should pay attention to Polkadot, because we don't have that great of a reputation outside of our bubble. But other than that, yeah.
Polkadot is the brand of the network. Jam is the brand of the technology. It is perfectly reasonable for the network to stay and the technology to change. And it's also perfectly reasonable to want to communicate that the technology has changed. It doesn't mean that the network changes its brand. just means that we're being upfront about the fact that the network has new functionality and a new underlying technology bed.
Thank you for this statement. Last statement was really very clear. Another thing is, it seems to me that GEM will require beefier hardware, and how this will impact decentralization and resiliency. And the second question is for governance. Who will decide and vote on technical upgrades on the GEM chain, while Polkadot.OpenGov, I expect, will be on the core chain service, and it will be related to everything like, Polkadot related and system chain and these kind of things. If there is already some idea about this.
To maybe comment on the OpenGov first. OpenGov being hosted as a parachain on core chains doesn't mean it doesn't affect the rest of GEM. If core chains will be a service running on GEM and OpenGov exists there, it doesn't matter if it exists natively on an OpenGov service or if it exists in core chains and then the parachain. The origin shouldn't be meaningful here. It still can affect the decision making of the protocol, just addressing the OpenGov element.
Yeah, I mean, the way that GEM works, it has it retains a mapping of privileges. So different services can have privilege levels that allow them to do things like upgrade services, name services, change the validator sets, determine core time. Actually, they can't upgrade services, but they can give services core time, and so forth. And this is, we would have to, when we launch GEM, work out what the services are that are the privileged ones. And most likely, we'll see, but most likely those services will point to the system parachain, right? If we have a staking parachain, the staking parachain. If it all sits on a hub parachain, then on the hub parachain. And then it's up to that parachain to understand how to turn its state into privileged commands, right? So it would understand that if the staking parachain said, this should be the new validator set, to listen out for that and then turn it into a sort of jam command that told jam to upgrade its validator set, essentially being a proxy. So it's not a separate world, right? It's all very much part of the same system. It's just that the parachains sort of sit one level lower because there's a service that understands how to finalize and, how to check the correctness, retain the sort of head information, and ultimately finalize parachains. And that service also ends up becoming the proxy in case you want to effectively bestow privileges on system stuff to a parachain, including the privilege of upgrading the parachain's service. Right? That in and of itself is effectively a higher order privilege. That not everything in the parachain would be allowed to do. It's like if you imagine you've got like a hub parachain, a lot of smart contracts in there, you're not going to give the public smart contracts the ability to upgrade the overall parachain code. It would be reserved for like a sudo or some sort of root governance motion. Yeah. So this governance stuff still has somewhere to go. It's not that it doesn't have anywhere to go. It's just that it's a little bit more sophisticated than what it used to be, which was upgrade the world. Now it's upgrade this bit of the world, and potentially also have that other bit upgrade itself, but it's not it doesn't have the same sort of God-level privileges that it used to.
Maybe, I think with some simplification, we can even say they are more similar than not. 'Cause I think that the statement that might be causing confusion is like, you know, Jam doesn't have governance, and but then someone might think, oh, all the Polkadot OpenGov stuff is going away. Even today, like, we had this analogy earlier. There's like the Polkadot network and the Polkadot technology bed. And the OpenGov can dictate what happens mostly inside the WebAssembly logic, which is the Polkadot network logic. I think in the same way, it's fair to say actually OpenGov doesn't have direct power to like force the validators to, I don't know, change their binary. Like some parts of the technology bed is actually fixed already. And what we mean by Jam doesn't have governance in that sense is that this technology bed stuff, this part that we call the technology bed, is mostly fixed. And it then follows a different upgrade cycle. And you mentioned an editorial board to like dictate what the changes would be and so on. So yeah, more similar than change.
Hey guys, what will the migration from a relay core to a jam core look like for a parachain? Are there any technical risk associated with it, or will it be just a passive migration, like all parachains have to do is sit back and relax while Polkadot goes from relay to a jam core?
We'll do our best at parity to make it as seamless as possible. But at the end of the day, is moving not only from, you know, the relay chain to a jam chain, indeed from the relay chain to a service on the jam chain, but it's also moving from WebAssembly to PVM. So you've got a change in the execution architecture and the change in the instruction set architecture. It's not going to be totally trivial. But as I said, we'll do our best to make it as seamless as possible. Realistically, it's going to mean taking the Parachain code, recompiling it in a new SDK, uploading that PVM blob onto the relay chain prior to the switch to a jam chain. Then at some big bang moment, we will snapshot the relay chain, create a genesis block for the jam chain, kick off the jam chain soon after. At that point, the jam chain will have a parachain service that should have the PVM code hashes already in there, and the Parachain collators, after they're rebooted and upgraded, should be able to understand the PVM blob, make new blocks, and get them finalized. That is the rough plan. And Parity will be beginning to put the wheels in motion for that software development this year, like probably in the next month or two, as PokerJam stabilizes.
To comment on that a bit more, we have people already looking into like early speccing of the Parachain service, still very, very early. And we also have people actively trying to already have PVM working for Parachains before the jams transition, so teams can already transition and they can essentially choose WASM or PVM, not just for the purposes of snapshotting and transitioning, but actually using PVM even before that to essentially stretch out the transition and make it a bit smoother instead of one big shock where we have more things that can break. And this should also just help the process go easier.
So will Jam have the same separation of runtime and node, what we currently know? No, right?
The Parachains service on Jam
Yeah.
will assume
But
that
in the node
runtimes
of
are
Jam.
In the node of the Parachain or in the node of Jam?
On the node of Jam.
The node of Jam won't know anything about runtimes. All it
No,
understands
I
is
mean,
services.
so the core the chain service is in the node of Jam.
It only understands Jam services. Now, when it's executing the refinement of a Parachain service, the runtime will effectively be in there, right? But that doesn't sit on chain. That sits in the DA or the pre-image lookup service somewhere. So as far as the Jam chain's concerned, imagine like, I demoed Doom, right? Right, so there's a Doom executable somewhere, yeah? That doesn't sit, that never gets executed or even known about in Accumulate, which is the on-chain bit, right? Doom, the code, only actually executes in core, in refinement. And it doesn't do so, it's never uploaded as a service, because Doom has no idea what Jam is, right? Jam wouldn't know what to do with Doom. So it gets uploaded only as sort of guest code for the core VM service.
So how do you add a service to Jam?
There's a BIOS service, basically, right? The thing that I pointed at, the bootstrap.
Okay, I remember.
And
Yeah.
this lets you, this has, as part of its actual service code to add new services.
Okay,
Yeah.
okay. I see. All right.
Like any service can add another service, or as many as it wants, yeah? But there has to be at least one at some point, otherwise there is no service to add more services.
I think it would be useful eventually to add this as a material to PBA. Like, imagine in the Jam world, there is the Polkadot Hub Parachain, which would still be there, is running a PVM smart contract. From outside to in, what is the sequence of software that's running? How many VMs are spawning another VM and another VM? I think it's actually very good to go from outside. So it's like the Jam node is running a service. That's the core chains or parachain service. That's a PVM blob. This thing is running inside of it the Polkadot Hub or Asset Hub, as we know it, the runtime, which is another PVM bytecode. And this thing is spawning a contract, which is also a PVM bytecode.
I think that's the key, because PVM, because you can spawn multiple sub PVMs, then you can have just the Parachain service be one service and it just has all the blobs and it just picks the Parachain blob that it should be and executes the code and makes sure everything sits well with Jam.
So refine is stateless, but we also know the cores run in parallel. So how exactly does data get fed into refine, or what kind of data is passed into refine?
So data comes from a couple of places. 3, kind of. First place is just data that is part of the work package. You can think of this as being akin to transaction data in smart contract networks. It's like data that's bundled up with the specific compute instruction, right? The user data, the data that's sort of coming in when it's when we are telling Jam to actually go ahead and do something, right? We call this the work item data. The extrinsic data is how it's referred to in the grey paper. The second data comes from the DA, right? And this is that big library that I was talking about, with every book being 4K big. You can have up to 12 megabytes of this data combined per work package. In reality, they amount to the same thing. The only difference is that with the DA input data, the validators of Jam have to do an extra step. They have to go and reconstruct this data from other validators, right? So it can take a little bit longer for work packages to come through the pipeline if you're using this DA functionality. In principle, that could be rewritten so that it is the builders that sort of have to reconstruct from the DA, still via validators, one way or another, and then that everything just gets bundled up as extrinsic data. But it's sort of equivalent. And then the third data source is pre-image lookup data. This is data that's actually stored on chain using this pre-image lookup system, and this comes for free, basically. It's much, much cheaper than DA, and you haven't got the same limits. Why? Well, because the nodes already have it stored. Every node, every validator node has all pre-image lookup data. That's its nature. But it's much more expensive to put in because you're using up chain storage. So that's where the data comes from.
And to continue on that, this also shows how we removed some of the assumptions in Jam. In the original Polkadot, when you had parachains, you always had to provide the POV of all the elements you're changing from the state of parachain. Here, you can still provide it as part of the extrinsics, but it's no longer an assumption that you have to provide it. You can have different types of extrinsic, different types of processes that don't necessarily require this contextual data. But you can expect that the Parachain service will be expecting this as part of the input data to also provide the POV necessary for the computation.
Hello, Luca here. Are there any benefits of Parachain switching from the relay chain to Jam chain? And is cost going up because the specs are going up for the Jam chain if we look at the relay chain specs?
Costs. Well, benefits are easy, right? Oh, do you want to?
I can make a comment at least. In my mind, when you say have a parachain move from the relay chain to jam chain, you're talking specifically still in the parachain service, or just like directly? Because in my opinion, something like the parachain service really is like this service for distributed ledgers, right? So if you're today creating a distributed ledger or like a blockchain, this is the service you go towards. But other services on Jam may not quite look like blockchains, or may not look something quite different, right?
Oh, I mean like switching from relay chain to Jam chain and parachains connecting to it. So will it benefit to parachain something?
Yeah, so we will move, or the plan is to move the relay chain to Jam chain. So they will have to move, kind of. But they will, so yeah, the benefits are easy. So when they move, they will have, one of the things, if they use PVM, we might get metering to work. So we might get some parachains that don't want to do benchmarking, might be able to just do metering. Of course, you can do benchmarking because it's a little bit more efficient if you manage to get it correctly, but then you could also do metering. And then it should provide more, I'm not sure if you just switch, if you get any benefit on like throughput or anything, but it does open the door for later improvements.
And cost of running the parachain and verifying on Jam chain?
So if you're just running the Parachain collator, it should be the same thing. You're building para blocks and sending them just to a different place. I think that shouldn't change much. If you just mean like running a binary for the Jam chain, then that's a totally different thing, and it varies a lot.
I mean, you pay for the shared security, right? From the parachains, right?
In theory, it should be cheaper, because in theory, we should have more throughput, no?
Yeah. We'll see how much throughput we get. We are cheating at the moment with the Polkadot relay chain and WebAssembly. We're not actually metering how much is happening when we validate a parachain. Now, the reason that we can get away with this is because we have this really annoying all or nothing timing protocol as part of the relay chain that basically fires off the WebAssembly worker and then kills it if it takes longer than 8 seconds. And then we assume that probably parachains are kind of trusted code, which means it's unlikely that if it's coming from a parachain collator, it's going to be maliciously engineered to always take more than 8 seconds and therefore stall the validator. This assumption is probably fine for Parachain. It doesn't really work for services in general because services are much more permissionless. It's also questionable whether it really works under agile core time assumptions. So it's definitely a portion of the protocol that we consider quite weak and want to replace, and that's why it's being replaced with PVM and proper metering. Because we have proper metering, there is an efficiency question. Before with WebAssembly, we basically just let it run as fast as it can and hoped that validator nodes could basically agree on whether it took longer than 6 seconds. Can't do that if it's just arbitrary services that are running for arbitrary numbers of compute steps, because you don't know whether one service maybe took longer than its share of 6 seconds or another service took longer than its share of 6 seconds. The whole thing gets very intractable. So you do need objective metering if you're to go into this design direction. This probably means, and we don't have the numbers yet, but it probably means we're not going to be able to actually get that much more throughput on what we got with WebAssembly in Polkadot 1 in terms of compute. In terms of smart contract, it's a different story, because the smart contracts that we're executing in, say, Palette Revive in Polkadot 1 were not using the WebAssembly compute system. They have their own interpreter, right, that are coded in WebAssembly, but are actually just an interpreter for, whatever, EVM, WASM, PVM. And this is where we get our speedups, because we can now reuse the PVM metering machinery that has to be used at the service level, where we can reuse it at the smart contract and the runtime level. So actually we're still going to get some substantial improvements at the smart contract level within Parachains, assuming that they use the latest, the new API for kicking off PVM smart contract execution. It's already been mentioned, benchmarking. This is going to be a sort of pretty big deal that you'll be able to get away without benchmarking. Again, the reason that we needed benchmarking was specifically because of this little cheat that we'd done at the PVF runtime level, where we basically said, we'll just agree on whether it took longer than 6 seconds or not. We won't agree on exactly how long it took. This led to the need for Parachain teams to do benchmarking, which led to quite a lot of expended development effort that wouldn't otherwise be there if it was something dynamically metered, and also leads to the potential of sort of maybe bricking your node if your benchmark's off and someone comes up with a transaction that does take longer than 8 seconds to verify, to get through your runtime. Then suddenly the Polkadot validators are going to be annoyed, A, that they're spending 8 seconds verifying 6 seconds of work, and B, they're just going to stop validating your Parachain blocks and therefore brick your chain. So the whole thing is a lot more robust under the jam model, and I think that will sort of shine through a bit. One other potential thing, and it's not something that's going to be out on day one, but it's something that I think might even be people in this audience are able to contribute to. And that's this old idea of essentially having smart contract intermediaries between parachains. The idea was called Spree, that's right. And then later renamed kind of to Accords. And the idea, it's one like Accords, right? It's like having a sort of law between parachains. Yeah, so you can kind of basically have parachains agree that they will respect some system of balances so that when they send tokens between each other, even though they don't trust each other's parachain logic, they can trust the logic of the smart contract that is sort of managing the balances that are shared between them. Yeah, and this can have some nice benefits to parachains. For example, you can imagine XCM message routing that is daisy-chained between parachains. And the parachains don't necessarily trust each other, but they can trust that the XCM message they got was correctly executed by everyone before them in the daisy chain, and will eventually make its way to everyone after them in the daisy chain. Yeah. So yeah, I think there are some interesting feature additions that we'll see for parachains, but not necessarily compute throughput directly.
How would you do accords though? Like, do you need to interact between the parachain service and a core player, a sort of smart contract service? So you go through the transfer and then send them some memo and
probably, yeah, I mean, maybe. I would probably put it in the Parachain service itself. So the Parachain service basically has a smart contract repository, right?
A question here.
Before we continue further, one more thing. There's also a bit more aggressive parameterization of the ELSE protocol within JAM. What you know as backing groups in JAM is a bit tighter, which essentially leads to more execution cores, which will potentially make core time more available and cheaper.
Yeah, so if you want to do elastic scaling, you should be able to get more cores.
Yes.
If you want.
Although I wouldn't comment on cost at this point. So JAM may very well be able to provide quite scalable levels of cores. Like at the moment, what Polkadot's got, 45, 50 odd. JAM is targeting 341, right? So quite a lot more. But those cores have to be paid for, each one effectively by the whatever it costs to get validators, to get disinterested validators computing the work done on those cores, right? And storing the data and all the rest of it. This isn't free. And if you saw I don't know if you did, but if you saw my talk that I gave earlier this year at the Web3 Summit, you know, you did a little research. It costs probably around 500 million a year at the moment to fund those 50 cores, right? So the cost, if we split it between cores, is quite substantial. Now, to some extent, Polkadot Economy is probably going to subsidize this, particularly for the Polkadot Hub, right? But make no mistake, at the moment, parachains are getting this core time cheap. Cheap as chips, yeah? And that will need to change long term to make a sensible economy, yeah? A broken assumption used to be, and it's not an assumption I hold, and I'm not sure it's an assumption I ever really did hold, but certainly an assumption that was prevalent in the ecosystem, was that if a parachain has a big enough public profile, it's worth it to pay this 500 million a year. I do not believe that is the case. I do believe parachains will need to be value-producing things. And they'll need to capture that value, and they'll need to give some of it back to Polkadot so it can pay the validators that make sure its compute is correct. That needs to be the economics, yeah? Don't think that by coming up with some random gadget that a handful of people use, that somehow this is valuable enough to Polkadot that you can get away with paying $100 a year for a resource that costs Polkadot $150,000 a year. Yeah? Ultimately, that will not be the case. And the reality is that the dot economy wouldn't support it.
Question here is fairly similar, I think. What is the plan for migrating from the relay chain to Jam as far as using a testnet? Like, I imagine you're probably using Kusama first, and if so, I imagine like the price of Kusama and dot is so vastly different. How would you determine, or like, what would your price finding strategy be? Which I feel both of these are similarly covered from the previous questions, but not quite.
So yeah, I do on the first point imagine that Kusama will be not thrown under the bus, but have its tires kicked first. And it's going to have more aggressive parameters, right? It's going to be on we'll see how what the toaster gives us, but the hope is it will handle a 1 second block time. So it's going to have much lower latency. But also, to facilitate that 1 second block time, much lower validator count. And hopefully that can be launched on a fairly aggressive timeline, probably not, we'll see. Kusama's sort of general vibe is to not do auditing first. So maybe we're not going to do auditing first. As for price finding, they're both tokens float on the market, don't they? So just have to see what the market says.
And when you're referring to a 1 second block time, do you mean that elves will still be scheduled every 6 seconds, or do we also want to speed it up?
Everything.
Okay.
So my question was about work items. Like we saw, the Doom service was broken down into like 3 work items. 2 of them were for the executable. So is that something the PVM manages for the service, or is that included in the instruction set for the service?
So it's not that it broke it down into 2 work packages. There were work packages once every 6 seconds that sort of ticked Doom along and computed the next 6 seconds worth of video and audio frames, right? There was the thing that was broken down into 2 bits was the file, the Doom executable. And this is because it's done as a pre-image, right? So it uses this pre-image facility. And there's a limit to how big pre-images can be as they're fed onto because they have to go onto the jam chain directly, right? There isn't the bandwidth for services to sort of give pre-image data into the relay chain. They go on as a special piece of data that gets included in the block itself, the jam chain block itself. And this data, the jam chain block's, I think, 12 megabytes. This data is limited. And we need much of this 12 megabytes for basically the information on what's going on in the cores. Yeah, the refine output, amongst other things. And therefore, there's only, 1.5, 2 megs of data, something like this, that is free for getting this pre-image data ferried into the jam chain. And therefore, if it so happens that the Doom executable is 3.5 megabytes, I think it is something like that, then you're going to need a couple of these sort of ferrying trips onto the jam chain, right? You have to split it up into bits, get them on the jam chain. I think, I can't remember exactly for certain, but I think the way that we've done it, this is a convention, this isn't anything Jam cares about. It just sees individual pre-images, right? Individual blobs, hashes them, and makes them available under their hash. But if memory serves correctly, we just have a linked list of the things. So we have, maybe we don't. Maybe we do have an index. Maybe we do have an index. But we essentially reference these things by their hash. Whether it's a hash at the end of a link, at the end of the previous one, or whether it's an index of hashes, and then we have to look up each hash in turn. I can't remember exactly which. But there is a convention for encoding or committing to many of these sort of fragments, file fragments, and then this allows the refine code to rebuild them, or the bits of them that it needs.
I have a related question to sort of the data ingestion of the service. The sort of extrinsic data comes in from the outside, so no control, right? The users choose what data comes in. The data that comes from the accumulate that you just talked about, presumably is available on the nodes, so it's easy to query. I have a question around how is the data picked from the data lake that comes into the service? Is that something that's happening as part of refine? So if during refine, I query, I want this part of the data lake? Or is this selected before the refine is called, and then like sort of where or how does that happen? How is the data picked that comes in there?
That's a good question. Strictly speaking, when the validator node is executing the refine code, all of the data that is fetchable from the data lake must be ready and waiting. So it's not that as the refine code is executed on the validator, it is delivering information to the validator about what DA inputs are. That's already specified to the validator. However, a good SDK and a good that's linked to the builder, a good builder, generic builder framework, will probably allow refine code to pretend as though that's what's happening. So the refine code, when it's executing on the builder, will get halfway through refinement and say, oh, actually, I need this bit from the DA. And it will magically just be there. Of course, at the builder stage, the builder will grab it from DA, put it on a list, suspend the code until it gets it from DA, and then carry on the code once it's in place. Or maybe even carry on the code, but give it a future, so that only when it tries to use the data, it will actually block on the data being available. Yeah, and in the meantime, go fetch it in some asynchronous channel, probably from validators, or maybe from its own cache. Yeah? But this is all SDK stuff. From the JAM, from strictly the JAM protocol's perspective, once the validator gets the work package, it understands exactly what data from the DA is required.
How will be for validators? Because, I mean, currently JAM has been tested on the Gem Toaster, which is quite a controlled and, to say, like, standardized environment. Mm-hmm. And will validator need to upgrade their machines? Will the spec of this machine be available by most service providers, or will be more like Bitcoin or, I don't know, other network that need beefier stuff, or specific, specific machines that cannot be very different from each other, you know what I mean?
There is a standard hardware spec, right? This is, you can think of this as like a minimal hardware spec. It's not going to be mad, right? It's going to be consumer grade hardware. A decent AMD Threadripper, like probably 16 core, maybe at a push 24, but probably 16. I don't know, like 48 gigs RAM, maybe 64.
Are you not afraid that this will lead to massive centralization of, I mean, these are devices that are not available?
I think what he just said sounds very reasonable. I mean, compared
Okay.
to the kinds of crazier hardware that other systems use, this
Like
is consumer grade.
Solana has like 512 gigs of RAM, please, requirements, you know? This is gonna cost, this machine that I'm describing probably costs certainly under 5K, right? Probably 1.5 if you're cost conscious.
If you're like a YouTuber doing like computer stuff, this is the computer you see in the background with all the lights. Like this is pretty reasonable. And I assume again, if the spec updates every year and a half, we probably update the hardware every year and a half as well. So we get the latest, greatest, and jam sticks faster.
No, I mean, there's a balance to be made, right? You know, if you want something that is going to be as performant as jam, you kind of have to give it a bit of grunt and a bit of uniformity of hardware. If you want to be able to rock up with your Texas Instruments calculator and still be able to process blocks or be a validator node, that's fine, but your network is going to look a lot different. Your protocol is going to look different. And your developer experience and probably realistic applications that you can deploy to it are going to be a lot different. If you want a decentralized supercomputer, you are, to some extent, going to need to have uniform hardware that is reasonably well interconnected. Now, of course, you can take this to its limits and say, right, well, we're going to require 512 gigs of RAM. We're going to require, you know, 1 petabyte of storage. We're going to require multiple 10 gigabit interconnects. Yeah? This, I would say, is going too far. The idea is to make it, like Sean says, enthusiast level. Nothing that an enthusiast couldn't reasonably afford or build or host. Yeah? It should be hostable on a good quality home internet connection. Yeah? Not data center, 40 gig uplink connection. Good quality home connection. Gigabit, but actually gigabit. Yeah? That's the sort of level that we're talking about. That's the level that we're targeting. And as that level of hardware and interconnect improves, then we will take the standard requirements up. But we're also not going to do the Ethereum game of trying to get, you know, randomers with some 5-year-old laptop and mobile connection to be able to validate. That's not a sensible direction, I believe.
I think this is also where protocol flexes, because if you take like the single core blockchains like Solana or Ethereum, they are only as fast as their single computer on their network, often a little bit slower, right? What's interesting and amazing about the protocol that we use, like Polkadot and what Gem has, is that we're actually getting a multiplicative effect. Like we can provide a decentralized computer which is more powerful than any one machine on that network, which is, again, this is why we're actually able to do something like consumer grade hardware, but achieve results that you would only be able to achieve if you were fully centralized.
Yeah. And I mean, this is why, you know, you remember when I was at the beginning of my talk, and I put the little sort of diagrammy thing up, my visualization of Ethereum, yeah, and there was, you remember, there was a few little blue arrows, and then a lot of space, and then a few little more blue arrows, yeah? That lot of space corresponds to the fact that in an Ethereum, what is it, 12-second block, 15-second block? I forget. 12-second, I think, right? About, at most, half a second of compute is done, right? At most. And that's when the smart contracts that are executed are taking the EVM to its limits. And that's on crappy hardware. most Ethereum validator hardware can process most blocks in well under half a second. Yeah? Which is mad. That means that Ethereum is the Ethereum network is spending, 98+% of its time doing nothing, just idling, effectively. And this is where we get one of those, or indeed a couple of those orders of magnitude improvement in JAM, because we have this effectively like pipelining mechanism where refinement is back to back. Yeah? We don't worry too much about making sure every node on the network knows about every refinement before the next one. Ethereum has to do that because it's single-threaded effectively. Yeah? Solana has to do it too, it's single-threaded. I mean, they'll argue, oh no, we use multiple cores. It's like, sure, but you have a resolved state at the end of your, whatever, 1 second or half-second block time. Yeah? And that means all of the nodes that are expecting to keep up on the network have to be aware of this resolved state. Yeah? Which means it's not pipelined, which means you can't use our little tricks that we do. And we have a few other tricks as well, but this is one of the important ones.
Also, to comment a bit on the number of validators, there is a significant diminishing returns when you get like a lot of validators, especially if the protocol is not properly utilizing them. With NPOS, we're still selecting a subset of them to be in the active validator set. If you would have 100,000 or 150,000 of the inactive validators, this is not such a major game changer to the security of the whole protocol. And when referring to the actual hardware requirements and the bandwidth requirements, like I was recently browsing for new like internet providers in UK where I live, very easy to get like this level of bandwidth for a consumer, and it's actually really affordable. My uncle was recently looking in a different country in Europe, also really available. So bandwidth is not as limiting here. And the hardware, I think it's a bit better than my personal PC I use for like gaming and other stuff. So it is good hardware, but it's really available and achievable hardware. So I don't think it will lead to major centralization.
And just to add on to that, remember there's only 1,000 validators. So it's not that we are targeting this so that every person on Earth can run a validator node, or indeed a node that is meant to be sort of syncing the validator network. We'll have, light clients for this sort of thing, so that everyone can run a secure node. But they won't need to keep up with even the jam chain, right? And the jam chain doesn't keep up with everything that goes on in its cores. Just make sure that they're correct. So it's like 1,000 nodes. So it's reasonable in my mind that we have not entirely trivial hardware for them.
Can you tell us more about proof of personhood, or it will be upgrade coming in JAM, and what will be the impact of this?
It doesn't have much to do with JAM. In fact, it doesn't really have anything at all to do with JAM. It's the logic behind the proof of personhood stuff is very much based on Parachain, it's pallets, which should be an indication to this audience that the Parachain paradigm is not displaced by JAM. But rather it will be augmented with other paradigms as they are useful.
Hey guys, quick question about the benchmarking versus gas metering. How is objective metering, how is it decided that what will be the frame of reference for objective metering? Because in benchmarking we have the reference hardware, right? And that is precisely what we will be benchmarking for, or at least that's what we will be recommending the node validators to use. There's no, I don't see any frame of reference in objective metering. How is that working?
Another good question. And it's a shame that Jan isn't here, because he is the man on this. Roughly, we take the standard hardware, which, as I said, is one of these Threadripper cores. We fill up the other cores with work as we expect it to be done, so that the core itself is operating under a loaded CPU. And then we run a series of benchmarks, basically, of PVM code. And then there are some very particular gas metering tricks that we do to model the expected behavior, or in one case, coerce the expected behavior of the CPU according to our model. And we end up with basically a understanding of how much a given PVM, not actually instruction, but blob of code will take to execute. We call the time it takes to execute gas. It's the same thing. We may as well just call it execution time. But gas is shorter than execution time. The thing that matters is being able to take what we call these basic blocks, these basically chunks of PVM code that sit between conditionals, and understand how long, at most, they'll take to execute. Yeah, the gas cost, or the maximum time it will take standard hardware to execute it. And we want to make that estimation be as close to actual time taken, but not lower, at least not lower, not lower such that it can be engineered by the code. We don't mind if it's lower from time to time, as long as that's basically a random occurrence. Yeah? What matters is the maliciously engineerable average. So we're working to some very particular engineering constraints, and at the moment in the gray paper, if you look at the PVM section, you'll find that every instruction comes with a gas cost. This is not how it's going to look in 0.8 series. In 0.8 series, there will be probably a quite long, quite dense single function that has as input a basic block, which is to say a series of PVM instructions, and its output gas, or worst case time to execute. And that is going to be a very complicated equation that will be determined through a combination of understanding processor microarchitecture and its various cunning, understanding the amount of memory that is addressable at that specific time, and therefore understanding the possible cache operation, and understanding the sequence of instructions, potentially even some instructions that made up the last ones executing of the previous basic block, and the instructions of the current basic block. And with this information, it should be possible to build a fairly accurate execution time estimator. That's our expectation. Jan's current little project, and we're hoping to see some good results in the coming months from it. And it's that will lead to this, to the 08 series and the final gas estimator or / definition of the protocol. And that's the last major component, right? But it's important we get this right, if it's not already obvious, because this is the actual limit of work that can be supported in JAM. Because we insist on gas being secure, this limits us, not how fast we can do things in the best case. We already know we can do things really fast in the best case, but how well our metering model corresponds to actual maliciously engineerable CPU execution speeds.
I heard the gas meter stuff in Ethereum was based off what the laptop you were using to code at the time. So you were doing this, and whatever your poor laptop was telling you, this was the numbers.
Not just, actually. So we were Ethereum, Vitalik, Jeff, and myself were sat in my office in the Berlin Ethereum dev office at the time. I don't know, it must have been like June 2015, right before the network launched. And he had Pi Ethereum, and we just basically went through every instruction of EVM and just did a loop of 1,000, timed how long it took to execute for each instruction, took the average between the 3 implementations, and that was what went in to the yellow paper. So that was a substantially more naive approach. I mean, it mostly did the trick, apart from the Shanghai attacks, of course, where it turned out that our means of estimating, what was it, the exponentiation, the power function, I think, was flawed. Yeah, this is the limit to how much work you can do. It's why Ethereum, well, one of the reasons why Ethereum can process such a small amount of information. And it's something that, as I say, we want to get this right once, so that we don't have to write SVM and EVM and any other VM as part of the JAM protocol. Because if you get it right for PVM, and PVM is basically optimal but deterministic representation of a modern CPU, then you don't have to bother making it work for everything else. You can just recompile them into PVM.
Question here. It's regarding the analogy that you gave with the Linux kernel. I'm just wondering, is there an equivalent of this idea of having privileged services as compared to maybe, services that are not as important? They just run in their own lane and they don't really touch other stuff. Is there anything like that in this thing? Like, for example, the Bootstrap service, of course, has to be there, as you showed in your demo, but can we have something which is maybe not as privileged? It can only touch a few things.
Yeah, I mean, services are permissionless, so you can create whatever you want. So the privileged services are just the protocol needs someone to decide, for example, the validator set, and not anyone can decide that. So the protocol can, or some service can define who is the privileged service that, for example, can set the validator set, or can assign core time, or can change who can change the validator set and so on. So in general, there are only 4, or well, I mean, there's one for each core, but there's a limit set of privileged services, and then the rest are just services that you can create, and you can have your own thing, whatever you want, as long as you pay for it, and you pay for execution and storage and so on, and you don't need to care about governance, or you don't need to care about how to get this privilege. You use permissionless, yeah.
So there's actually one new one that came in with 071. I think 071. Yeah, 071. And this is the ability to name, to be the naming, the registrar service we call it. And it's the ability to, basically when you create a service, you get given this random ID, right? This 32-bit random value. You saw that when I was doing the demo. Well, the registrar service has a special privilege where it can state what the ID is. And as long as it's not used, it goes through fine. Yeah? All of the services, if they try and state what it is, it just fails. But the registrar service is allowed to, and it works. And because there's only one, there's no name collisions, right? The other thing that was added that you sort of touched on was a privilege that basically construes the ability to set core time. Now, this happens on a per-core basis, right? And it used to be in the Jam protocol that there was a single service that could set the core time owner, right? Effectively the authorizer agent. It could set that for any core. Yeah? Just like there is a service that can set the validator set. Yeah? And a service that can reset all of these privileges. Now there is actually a service, a sort of service for each core. So each core has its own sort of privileged service, like it names its own service, and therefore is effectively a privilege to give or to denote the core time authorizer for that core. Yeah? What does this enable? Well, suppose you want to say, I want to have agile core time auctions working as they do for Polkadot for 100 cores. But for the other 241 cores, I want to hand that over to another core time auctioning or selling service that has its own logic, right? Maybe it sells core time once a year, once every 3 years, once every 5 years. Maybe it's about depositing enough DOT tokens, and as long as the deposit's big enough, your ability to command what happens on that core continues for another 3 months, right? Might be all sorts of different models. And by having cores be kind of owned by services, we can enable this functionality really easily. We can say, right, this service, which is the 3-monthly make a deposit service, that's gonna own core 101. And this service, which is going to be the 6-monthly rotating deposit service, that's going to own core 102. And we can basically denote services to cores and have them own the core, and own who gets to be able to command the core time of the core. So we can sell cores in different ways, yeah? Which, given that we are not yet clear on what is the most optimum cost structure for cores, kind of makes some sense, gives us some flexibility for the future. So yeah, there's that, there's the setting the validators, the manager, registrar. The only other privilege that we have baked into the Jam protocol that services can have is the free execution privilege. Normally, services are only executed if there's some work that has come in through refinement into accumulate, or if there's a memo that has come out of one of the accumulates and back in to the service. That's normally the only way a service can execute, i.e. when it's got some data to process, right? There is a third way, but this takes privilege. If you're mentioned into the free, always executed services, you get executed once a block with some free gas. And we can imagine that there might be sort of system-level services that we want to execute every block, regardless of whether a work package came in or not. Yeah? I mean, it's not really meant for this, but you can imagine that there might be some scheduling that you want to do that is very important. You might even want to provide a scheduling service to services. Yeah? One could imagine saying, right, we're actually going to take, I don't know, 5% of the available gas, and we're going to make it always go through this special scheduler service, which can then basically auction off this gas on a monthly basis to kick off other services via memos. Yeah? And then if you've got a service that's maybe like a DeFi service or a stablecoin service that absolutely needs to process liquidations on time and is willing to pay for that, then they could hook into this scheduling service. Yeah? And they wouldn't need to rely on work packages going through refinement and getting into accumulate, which potentially, I mean, we take some effort to make sure it's not easily sort of DOSable, but is necessarily going to be more DOSable than something that happens purely inside of the jam chain.
And when you execute this always accumulate services, like which operands are you working on, or what inputs do you take?
They don't get any. It literally calls accumulate with an empty.
With an empty thing, okay.
So, and they get some gas, and then it's up to them basically to look in their storage and figure out what they should be doing.
Hi. So this kind of leads to that question. I'm Nissan. So you're talking. So I had a conversation. I'm a builder, and I was talking about some startup ideas, and I got introduced to pallets and conversations with Sean and Mache. We're like, sometimes you need a small contract, sometimes things are there in pallets. Now with Jam coming along as a builder, how do I start restructuring my thinking to say, well, maybe I need a smart contract alone. I don't need I don't need my own parachain, or maybe I need do I need services now? How would you start telling builders like me who have ideas, trying to build Polkadot today, but also want to prepare for Polkadot tomorrow, how to structure their thinking about services, pallets, smart contracts?
As a builder that wants to get applications launched, don't think too hard about services at this stage. The SDKs, such that they exist at all, are not well maintained yet, and pretty bare bones. That will improve over the coming months. Initially, just to ensure that they are kept in line with the current binaries, the current PokerJam binaries at least, and the current protocol. But it will take some time before SDKs become mature. At the moment, you have to basically write your own off-chain logic to build work packages, right? All of this stuff is looked after for pallets and for smart contracts. So such that you want to build applications, don't think about Jam. It's presented here just so that you know, in the maybe in a year's time, it's going to be increasingly available. It may even be, on that time scale, be the basis for parachains, or parachain correctness. But don't worry that it's going to invalidate the existing sort of ways of doing things. Pallet Revive especially is likely to be quite well supported by Core VM and whatever comes after it. Core VM is sort of, I would say, a sort of version 0.5 of what we want to do with running code on Jam in small chunks, like smart contracts on Jam. But it's the smart contract SDK for Jam, at least the one that's made by Parity, is probably going to support stuff that goes more with minimal changes into Palette Revive. I don't want to make too many promises yet because I don't know exactly what it's going to look like, but that will certainly be our desired sort of thing to do. So yeah, what you've been taught so far, that's fair enough. And for what it's worth, in future PBAs, I would see a rebalancing towards Palette Revive over Polkadot SDK / Parachain's SDK, what I call it these days. I would look at the Palette stuff to be optimizing your use case when you know you have the throughput needs. And I would see, you know, Palette Revive smart contracts as prototype, rapid application development. And for Parity's, as Parity switches into an application development company, a product company, we will be making use of Palette Revive, of smart contracts, probably much more so than palettes. There are one or two use cases, like proof of personhood, where we do expect the throughput. We do want to support the throughput, so we go straight into palettes. But for all of the random little product ideas hanging off that, we use smart contracts. That, I think, is sort of how you should be thinking about things. And as I say, cast Jam aside for now. Wait until there's a nice, stable SDK release that gives you an SDK that you're happy with.
Okay, nobody else called me for a question to get my mic, so I assume we're reaching the end. Is there anything else you would like to add before we call it a day?
I'm not opening a Pandora's box, but there's like two things I think are relevant the students should hear or hear about, which is kind of like future even after Jam, which I think is core play and the grid. I don't know if anyone has words on that, but I don't know. I mean, those are quite big boxes, by the way, right? So.
Yeah. Okay. So I mean, core play is basically a continued development of core VM. So what you saw with core VM involved asynchronous, you know, and you saw the message processing stuff, right? Transfer, send. This is an asynchronous messaging system, and this allows core VM instances to send messages between each other. Yeah? But otherwise, core VM instances, pretty much like processes on your laptop, are in like isolated things, right? They're not shared memory. Threads share memory by default. Processes don't by default. There might be a shared memory library you can use. I won't get into that. So core VM gives you stuff a bit like processes. I mean, in reality, like individual machines. Core play, the idea for it is that it is synchronously, these things have become synchronously composable, at least when you're willing to pay for synchronous composition. How? Well, actually, one of the answers I gave at the end of the talk was how, right? Basically, you're going to have co-scheduling. So a builder is going to build for multiple core VM instances at the same time. There becomes a question, actually two questions. The first one is it just one builder that builds for all core VM instances across all cores? In which case, that's kind of centralized. How do you manage censorship? And how do you manage, you know, what does that builder hardware look like? It's going to be huge, right? And the second one is, assuming that that's not the case, how do you manage the possibility of collisions? How do you manage the possibility that two separate builders will each build for the same core VM instance, and they'll do two separate things. And then when they eventually come to accumulation, you'll get two inputs into accumulation that are incompatible, right? That are premised on two different sets of synchronous composition and input. The answer that I see anyway is to have core VM instances associated with a particular builder network. Not a single builder, but a builder network, a network of builders. Imagine like a network of collators for parachains, yeah? And this network would have a leader rotation that would partition the core VM instance space in a way that maximized their own profit, and we'll assume for now they'll take 10%, right? So all of the profits that are made by running these core VM instances along and combining them synchronously, more importantly, 10% of it is taken by the leader, but the leader rotates. We might also assume that the leader doesn't have to rotate, but where the leader would have rotated to has the option, if they don't insist on becoming the new leader, to split it 50-50. So 5%, 5%, right? And this allows some degree of stability and therefore high efficiency without giving up, or at least totally giving up, on censorship and generally decentralization. Now, it's still a hard thing to partition. What we're talking about here is basically an agent space, like a smart contract space, but more generally an agent space, such that agents within the same partition have a high degree of value production through interoperation, and those that aren't in the same space have minimal. That's a hard thing, and it will probably require some special programming constructs so that software itself can make clear about what its preferences are. Maybe there'll be ways of doing it automatically in due course, but my expectation is that the sort of guest SDK is going to have some facilities for doing this, for sort of advertising. Hey, actually, I need to be around this agent for a while. You know, it's going to be in your interest to put me next to them. Beyond that, it then just becomes a case of the builder, who presumably is building for a single core, optimizing which smart contracts / actors they execute and in what order. Yeah? Basically, how they schedule what is at the end of the day just a synchronous set of computation. And this is a more solved problem. This is stuff that operating systems do on a pretty everyday basis, right? They have a bunch of tasks that they need to execute, and they tend to choose the one that can get the most work done. And there's usually some way of a task advertising whether or not it can do work, and if it can't do work yet, what needs to change for it to be able to do work. Yeah? Some might know some of these primitives already. So yeah, that's how the problem breaks down, and that's core play. And why is this good? Well, basically it gives us synchronous composability across a whole universe of smart contracts that are parallelizable across any number of cores. It allows us to use JAM's cores in parallel whilst still retaining synchronous composability when you need it, when you're willing to pay for it. And this is magic, right? This is something that has not been achieved at all. It allows not quite indefinite scale, but close to. Why do I say not quite indefinite? Well, because there's only 341 cores, but they do go quite fast. So the amount of compute and data throughput open to smart contracts will become huge. And their ability to compose with each other will not quite be unlimited. It's still, at the end of the day, the amount of composition you can do within a single core for any given composing partition. But again, that to a large extent is groundbreaking. It just rewrites the book on what you can do in a smart contract platform. Now, the grid, and I would caveat this strongly with, we need to make sure that what cores are doing produces value enough to pay for validators, right, to secure their compute. This is a very important caveat. Until we solve that little problem, there ain't much point spinning up more jams, right? But the grid is the idea that you can spin up more jams and hook them up to existing jams, or indeed the one existing jam initially, and essentially extend the number of cores beyond 341. All right? Now this comes at the cost of extending the validators, and therefore extending your rewards and costs and outlays to validators. So you've got to make fairly sure you're going to be able to make that back if you want to keep the economy going. But assuming that there is substantial ability to deliver value from cores, and the supply of cores is outstripped by demand, right? Demand outstrips supply. Then this provides a route to expanding the scale of Polkadot well beyond even this mad scalable level. And the nice thing is that the way that Jam is architected, basically by making a lot of this stuff asynchronous and by splitting refine from accumulate, which might seem complicated and long-winded and annoying, it means that we can have refinement happen in one jam in the grid and accumulation happen in another jam in the grid. Yeah? And from the perspective of the service, it's no different. Which means we can scale a core play service even beyond a single jam, if we're careful. And this is magic squared, right? This allows us to do synchronous composition across not just 341 cores, but potentially 341,000 cores, right? Now the grid works actually in a pretty easy way. It's really just about ensuring that validators are randomly dispersed between jam instances. There's the question of pre-image fetching. That will become a slightly more that will require service operators to ensure basically that all pre-images that they're going to use exist on all jams that are going to be able to process that service's refinement. And then there just needs to be a jam bridge, right, between all jam instances on the grid. Think of this as the high capacity interconnect that you might see in a literally a sort of cloud or grid of servers, right? In the old days, it was called grid. Before cloud, there was grid, right? And this was basically just a lot of fairly high power machines with high throughput interconnects, right? And then you would use something like, what was it? OpenMPI? SL, OpenM? MPI, yeah. There are a couple of protocols that essentially allowed you to use standard inter-process APIs, right, in order to take your code that would normally just run on a single machine, but on many cores, and make it work across a grid of machines. Well, that grid concept required high throughput interconnects. Well, the jam grid would require high throughput interconnects too. And we call these the bridges, right? That's basically just the bridge between jam instances. And you would have high throughput interconnects, probably just on a pairwise connection of all jam instances in the grid, which sounds kind of mad, but actually, if the value is being produced, it's fine. It's just there's going to be a lot of off-chain workers out there, right, that are basically ferrying data and oracleizing it into a destination jam. But yeah, economically and operationally, it's fine. It's just a lot of pieces to imagine. But as I say, it's caveated by the ability to use cores valuably. So let's do that first.
I think that's great. I think it's just such a clear vision for how we actually achieve a world computer, right? So.
Indeed. Make no mistake, Polkadot is the world supercomputer.
Awesome. Thank you so much. So with that, we're reaching the last discussion, panel, lecture. Thank all of the guests, Dr. Gavin Wood, Kian, Sean, Cisco, Mathieu. Thank you all. Thank you, everyone. Give it up. Thank you. Thank you. Now let's go for graduation and party, yeah? Let's do that. Thank you all.